Hello students, welcome to my study channel. Today we will work out the problems of exercise 3.1. This is of class 8 NCERT Maths Book. Okay, so let us start. And here you see the question number 1, already it is in your book and just I have mentioned here. And you see different figures. We are having some figures 1, 2, 3, 4, 5, 6, 7 and 8. And it has been asked, which are the simple curves? You know, simple curves, that means curves which do not intersect themselves. A simple curve never intersects itself. So, in this case, you see this figure, this figure, this figure, this figure and this figure. 1, 2, 5, 6 and 7. And you see here, they never intersect themselves from 1, 2, 5, 6 and 7. And number B, which are simple closed curves. And you see, the figure 1, figure 2, figure 5, figure 6 and figure 7. They are simple and also they are closed because they begin and end at the same point. They are closed. You can see 1, 2, 5, 6 and 7. Then come to bit C. We have to pick the polygons. You see, polygons already you know. It is a simple closed curve or figure that is made up of line segments. And you see, here there is no line segment. No, here only 2. This is not a line segment, but here you can see 1 and 2. These two are polygons because they are simple closed curves and they are made up of line segments. Then come to D, we have to pick convex polygon. You see, how you identify convex polygon? You see here, you see this vertex, this is inward, okay, this is inward. And how you know that this is a concave polygon and or it is a convex polygon? We have to see. So you can see that one of the diagonals must be in the exterior in case of concave polygon. And you see, what is diagonal? That is a line segment between two non-consecutive points. So this point and this point are non-consecutive points. So if you join these 2 points, then that will be one diagonal, but that remains in the exterior part. So this is a concave one. And how? In other way we can know. You see, one of the interior angles must be greater than 180 degree. The measure of at least one interior angle that must be greater than 180 degree in case of a concave polygon. So it is a concave polygon. Come to here and you see, in case of convex polygon, the diagonals you see like this, and if you join in a straight path, 2 diagonals and they lie in the interior in case of a convex polygon. And how in other way we can know? And you see, each exterior angle must be less than 180 degree in case of convex polygon. So we have to pick convex polygon. So figure 2 is the convex polygon and figure 1 is the concave polygon. So question number 1 is over. So this is over. Just I have picked the figures of question number 6, but after question number 1 we will move to question number 2. What it demands? How many diagonals does each of the following have? A convex quadrilateral. You see, convex quadrilateral. It may be a convex quadrilateral or it may be a concave quadrilateral. That doesn't matter. But the diagonals will be 2. How? Now you will put the formula. You see, quadrilateral means it has 4 sides. A quadrilateral is a 4-sided polygon. So a quadrilateral has 4 sides. So to know the diagonals, so number of diagonals, you remember this, is equal to n whole into n minus 3 divided by 2. Here n is equal to 4. Number of sides 4 into 4 minus 3, that is 1 divided by 2. 2 1 is 2, 2 2 is 4. You see, what is the number of diagonals? That is 2. And you better understand, you take any quadrilateral and you can find. And question number B, regular hexagon. Regular hexagon. And in case of a hexagon, you see the number of sides, there are 6 sides. One hexagon has 6 sides. So what are the number of diagonals? 6 into 6 minus 3 divided by 2. That is equal to 6 into 6 minus 3 is equal to 3 divided by 2. 2 1 is 2, 2 3 is 6. That is 9. So a regular hexagon have 9 sides. In case of a triangle, you see there are no 2 consecutive points to draw a diagonal. So that is 0. Number of diagonal is 0 in case of a triangle. And if you put the formula, you see 3 into 3 minus 3 divided by 2. That is 3 into 0 divided by 2. That is equal to 0. So number of diagonals is 0 in case of a triangle. Then we will move to question number 3. What is the sum of the measures of the angles of a convex quadrilateral? Will this property hold if the quadrilateral is not convex? Make a non-convex quadrilateral and try. And you see the sum of the measures of the interior angles of a convex quadrilateral or of a concave quadrilateral. It is always measures 360 degree. It may be a convex quadrilateral or it may be a concave quadrilateral, but the sum of the measures of the interior angles of a convex or concave quadrilateral, it will measure 360 degree. Okay, and you will have to remember this in case of a quadrilateral. And as the number of sides will develop, then the sum of the measures of the interior angles, that will vary. Okay, and just we'll do the question number 4. What it has been asked? What can you say about the angle sum of a convex polygon with number of sides? And the number of sides is 7. N is equal to 7. N is the number of sides of the convex polygon. And we have been asked to know the angle sum of a convex polygon. That means the sum of the measures of the interior angles of a convex polygon whose sides are 7. That is the heptagon. It's okay. And you will have to put the formula like the diagonals to know the sum of the measures of the interior angles of a polygon. If you know their sides, so there is a formula and we will have to apply. What is that formula? N minus 2 into 180 degree. This is the formula you will have to remember and put the formula and get the answer. N is equal to 7. So 7 minus 2 into 180 degree. That is equal to 5 into 180 degree. That is equal to 900 degree. So the sum of the measures of the interior angles of a heptagon, that is 900 degree. It is a convex polygon having the number of sides 7. So the sum of the measures of the interior angles is 900 degree. Then n is equal to 8. So 8 minus 2 into 180 degree, that is equal to 6 into 180 degree, that is equal to 1080 degree. The sum of the measures of a convex polygon having number of sides equal to 8. In case of 10, you apply the same formula, 10 minus 2 into 180 degree, that is equal to 8 into 10 minus 2 is equal to 8 into 180 degree, that is 1440 degree. And if the number of sides be n, so this is the formula, we do not know the value of n, so n minus 2 into 180 degree. What happens actually, you see, n minus 2 gives how many triangles? Actually what happens, you see, n minus 2, that gives the number of triangles. So you see, when n minus 2 is equal to 5, that means you see, in case of a convex polygon having 7 sides, what happens? Now we find 5 triangles, and each triangle, the interior angle, the sum angle according to the angle sum property of the triangle, the sum of the interior measures of the interior angles is 180 degree. And how many triangles? There are 5 triangles, and we get it when we subtract 2 from the number of the sides. So we have just developed a formula, n minus 2 into 180 degree, to know the sum of the measures of the interior angles of the polygon. So next, what is a regular polygon? We know a polygon with equal sides and equal angles, which we call equiangular. A regular polygon is with both equiangular and equilateral. All the sides are of equal length, and also their angles are equal. So state the name of a regular polygon of 3 sides. So it is an equilateral. You know the equilateral triangle, that is a regular polygon. 4 sides, we are having a square. 6 sides, we may tell regular hexagon. Okay, so these are the answers. Then we will come to question number 6. Find the angle measure x in the following figures. So you see here, we have to find the value of x. You see, in all the cases, we find the quadrilaterals. And you see here, these are the interior angles. We know the sum of the measures of the interior angles of a quadrilateral is 360 degree. So here you see, so you take the sum, x plus 50 degree plus 130 degree plus 120 degree, that is equal to 360 degree. That implies x plus, so you add these 3, 120 plus 130, that is 250 plus 50, that is 300. So 300 degree is equal to 360 degree. That implies x is equal to 360 degree minus 300 degree, that is 60 degree. So this value is 60 degree. So this case is over. Then come to B. What happens here? You see this symbol, that means the symbol of this angle, that means this is 90 degree. So this angle and this angle, you see, this is a linear pair of angles. So the sum will be sum of the measure of the two angles will be 180 degrees. So if it is 90 degrees, so it is also 90 degrees. And already we have here 70 degrees, 60 degrees, then 90 degree. Then you develop the equation like this: x plus 90 degree plus 60 degree plus 70 degree is equal to 360 degree. And just you release, you reduce the value, you know the value of x. X plus, you see, 90 plus 60, that is 150 degree plus 70 degree, that is 220 degree. Perhaps I am right. That is equal to 360 degree. That implies x is equal to 360 degree minus 220 degree. You took away 220 degree out of 360 degree. Then this will be 6 minus 2 per 140 degree. So this angle will be 140 degree. So come here. You see the measure of two angles. You see they are same. They are of same measure. It's okay. And we have to found how many angles you see. 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4 and 5. And it has also 5 sides. So we have to know what is the sum of the measures of the interior angles of a convex polygon, of a polygon whose sides are 5, that is a pentagon. So we will have to know what is the sum of the measures of the interior angles. So what formula we will apply here? 5 minus 2 into 180 degree, that is equal to 3 into 180 degree, that is equal to 540 degree. It is not a quadrilateral. In case of a quadrilateral, the sum of the measures of the interior angles, it was 360 degree, but it is a pentagon. So the sum of the measures of the angles, interior angles, will be 540 degree. So what we will do here, you see this is 30 degree, this angle AXX, and we have to find this angle. You see both these two angles, they are a linear pair of angles. So the sum of the measures of two angles will be 180 degree. So if it is 70 degree, it is 110 degree, and if it is 60 degree, it is 120 degree, like this. So what we will do here? Now we will start from here. X, let it, we will add x plus 30 degree plus 110 degree plus 120 degree, and the sum will be 540 degree. That implies 2x plus 120 plus 110, that will be 230 plus 30, 260 degree. 120 plus 110, 230 plus 30, 260 degree, that is equal to 540 degree. That implies 2x is equal to 540 degree, 540 degree minus 260 degree, that is equal to 0, 14 minus 6, 8, 4 minus 2, that is 280 degree. So that implies what is the value of x? 280 degree divided by 2, that is equal to 140 degree. So these two angles will be, their measures will be 140 degree each in case of C. Then come to question number D. It is also a pentagon. So what is the sum of the interior angles? That will be 5 sides, 1, 2, 3, 4, 5. It is a pentagon. So the sum of the interior angles will be 540 degree. And it is a regular pentagon, you see. So all the interior angles are of equal measure. So how many x here? 5. So x plus x plus x like this. So that is 5x is equal to 540 degree. That implies x is equal to 540 degree divided by 5. That is 108 degree. So each interior angle will be of measure 108 degree in case of a regular pentagon. Okay? So this is for the question number B. Then we will move to question number E. Just I erase it. There is no space here. Just I erase it for figure E. And in case of E, what we have been asked here, you see. So it is a triangle here. One angle is 90 degree, it is 30 degree. So what is the third angle? What is its measure? Now from angle sum property of a triangle, we know the sum of the measures of the interior angles of a triangle is equal to 180 degree. So what is this angle? 90 plus 30, that is 120, then this angle will measure 60 degree. It's okay. So if it is 60 degree, it is both the two angles, the angle y and 60 degree, they are a linear pair of angles. So the sum of the measures of two angles will be 180 degree. So if it is 60 degree, this y will be is equal to 120 degree. If it is 90, then according to the linear pair of angles, x will be also 90 degree. And here you see the z angle and 30 degree, both are linear pair of angles. So if it is 30 degree, it will be 150 degree because that sum will be the measure, sum of the measures will be of the two angles will be 180 degree. So this will be 150 degree. Then come to last one. You see, it is a polygon having 4 sides. It is a quadrilateral. And the interior angles you see, if we take the sum, it will be 360 degree. So we have to know this angle, 60 plus 80 or 120 plus 80, that is 200 plus 60, that is 260. And this angle, 260 plus 100 degree, then this will be 360 degree. Okay? And we have to know x, y, z and w. And you see, these are the exterior angle. And we can know from the linear pairs of angle, you see here it is a pair, here it is a pair, here it is a pair and here it is a pair. And if it is 120 degree, then this will be 60 degree. If it is 80 degree, this will be 100 degree. If this is 60 degree, this is 120 degree. And if this is 100 degree and this is 80 degree. So these are the results. You see, and like this you have to receive the solution, you have to do the solution. So in the next video clip, just we will discuss about the properties of the quadrilaterals like that of the parallelogram, kite, and in some special cases we will discuss. Then we will proceed to exercise 3.2. And if you have not subscribed the channel, please subscribe the channel. Wish you all the best and we will meet in the next video.